Welcome to this video on how to scrape product data from Amazon. In this video we will use BeautifulSoup and ScrapeOps to scrape a page of product data and also an individual product's data and store it all in a CSV file. Before we get into the code, let's take a quick look at the Amazon website. Let's start by searching for phones. There are two page types we will scrape, this search results page and each individual page. As you can see, when you search something, it is added to the URL using the query param k. If we right click and inspect the product title, you can see the HTML that we will have to parse to get it. When we click a product and scroll down, we can inspect the product's features and also see how to get those through the HTML. If we go back to the search page, you can see how we can control the pagination by adding the page query param. So to start out, we'll create our projects directory called Amazon Scraper. We will change into that directory and we will create a virtual environment. We will then activate our virtual environment and install requests and BeautifulSoup 4. Once that's complete, we'll create a scraper.py file and start importing some of our dependencies. We'll import logging and OS and set up our logging by calling logging.basicconfig and passing in the logging level info. We will then call logging.getLogger to get a logger. We will define our ScrapeOps API key. You can get this in the ScrapeOps dashboard, and we will create the search products function. We'll set tries to 0, success to false, and we will create a while loop that says while the tries is less than the total retries and we have not been successful, we will create a URL for Amazon, passing our product name as a query param. We will then call request.get, and don't forget to import the request module. In our accept, we will call logger.warning, notifying that there was some sort of failure. When there's a failure, we will also increment tries by 1. If the response status code is 200, then we will log that it was successful. And we will take the response payload and pass it into BeautifulSoup to be parsed. We'll use the html.parser for this. Don't forget to import BeautifulSoup from BS4. We will then get all of the divs by saying soup.findAllDiv, and we will iterate over each one of those divs and set parsable to true if there is a div, and if not, we'll set it to false. Inside that div, we will find a h2 tag, and if that h2 tag has a value and it's not equal to the last title and is parsable, then we will strip the title and find a link inside that title. We will then pull the product URL from that link through the href attribute. Set the add status to false, and if the string SSPA is in the product URL, then the add status is true. We will set the ASIN to be the div.getDataASIN, and for the symbol element, we will find a span tag that has the class of a price symbol. We will then set symbol presence as a boolean, and it'll be if the symbol element has some text, and if it does have a value, then we will get all prices by saying div.findAll span, which looks for our span tags with the class A off screen. We will then find the rating element by finding the span tag that has a class a icon alt. And we will define if the rating is present by checking if the resulting rating element has text, and if it doesn't, we will set it to 0. We will then convert that to a float and store it in rating. We will then check to see if the price is present, and we will replace the pricing unit in that string and any commas with a blank string. If it's not there, we will just set 0 as the value. We will also convert that to a float. We will then set the real price. And if there is a symbol present, a rating present, and a price present, then we will define a dictionary called product, and we will assign the extracted values. Then we can just print out this dictionary. We can then set the last title to the title of the product. If that's successful, we'll set success as true, and if the status code was not 200, then we can raise an exception, just saying that we failed to scrape the page, and give the status code. Then, after we've done all iterations and all retries, we can just say if not success, and then do logger.warning. Then we can just print a simple message saying we've exited the scrape products. Then we can create a main function and define a list of products that we want to scrape. We can define the max number of retries, and then loop over each product and pass that product into our search products function. Let's activate our virtual environment and run the script. And as you can see, we're getting a 503 from Amazon. This is because we are getting blocked. We will fix this shortly. Before we do that, let's add pagination by adding page number to our search products function and to our Amazon URL. We will then import some other stuff like data class and field from the data classes module. And we will define a product data class that will take and hold our data that we scrape from Amazon. So we will define the same fields that we defined below. So name, title, URL, is ad, pricing unit, price, real price, etc. We will then define a post_init function, which gets called after the data class has been initialized. And in there, we will call another function called checkStringFields. We will then define the checkStringFields function, which will loop through all fields. And if the field is an instance of a string, we will check to see if the field is empty. And if the field is empty, we will just set it to some default value like n/a. We will then continue to the next iteration. However, if it's not equal to an empty string, we will just strip any trailing spaces by getting the value and setting the value to be value.strip. Now we're going to create a data pipeline. The data pipeline will take all of these data class instances and save them to a CSV file periodically. So we'll create a constructor that takes a CSV file name and a storage queue limit as an argument. We'll define a named scene list and a storage queue list. We will set the storage queue limit and the CSV file name. We will also create a CSV file open variable, which will determine whether or not the CSV file is open or not. We will create a save to CSV function, which sets the CSV file open variable to true, extends the data to save list by the storage queue, clears the storage queue, if there's no data to save, we'll return. However, if there is, we will get the keys for the file by simply iterating over the fields in the data class. We will then check if the file exists using the OS module by checking the path is a file and that the file has a size greater than 0. We will then open the CSV file in append mode, set the new line delimiter to a blank string and the encoding to UTF-8. We will create a dict writer instance from the CSV module, which allows us to write dictionaries to a CSV file. If the file does not exist, we will then write the header row, which will just be the keys at the top. We will then iterate over every item that we want to save and write it as a dict. We will then set CSV file open to false. We can now create an isDuplicate function, which checks for duplicates. It takes some input data as an argument and checks to see if that input data.name is already in self.names scene. If it is, we can log a warning and return true. And if it isn't, we can append that to the named scene list and return false. We could then create an add data function, which checks to see if the data is already added by calling isDuplicate. And if it isn't, then we can append it to the storage queue. And if the storage queue's length is greater or equal to the limit, which in this case is 50, and if the CSV file is not open, then we can call save to CSV. And finally, we can create a close pipeline function, which checks to see if the CSV file is open, and if it is, we can call time.sleep. And if the storage queue's length is greater than 0, we can call save to CSV. Don't forget to import the time module here. And now we need to do some adjustments to our search products function. We're going to get a list of bad divs by the class name addHolder, and we're going to loop through each bad div and decompose it. Let's replace the dictionary for product data with the new data class we created, and let's fill in the attributes that we defined. We're now going to call dataPipeline.addData and pass that product instance into it. We now need to pass the data pipeline into this function, so we can define it as an argument. And in our main function, we can create an instance of the data pipeline by simply saying product pipeline is equal to data pipeline, passing in a CSV file name. We can then pass this into our search products function. We can then call close pipeline to save it. We now want to add concurrency to speed things up. So to do so, we can import the thread pool executor from the concurrent futures module. Now we can define a new function called threaded search, which takes the product name, pages, max workers, location, and retries as arguments. In here, it will define its own search pipeline, passing in a CSV file name. And then we will use a context manager to create an instance of thread pool executor, passing in the max workers, and then creating a list of futures using executor.submit. We will define the search products and all of the arguments we want to pass into that function. And we'll do that for every page in the range from 1 to pages plus 1. To run these, we can now loop over each future and say future.result. And finally, we can close the data pipeline. We can define the total number of pages, the max threads, and the location. And then replace the code we wrote with the call to threaded search. This will then use multiprocessing to do the scraping. As you saw earlier, we will get blocked when we make a call to Amazon. So to bypass this, we will use a proxy URL provided by ScrapeOps. To do so, we can define a getScrapeOps URL function, which takes a URL, which in our case would be the Amazon URL. We define an API key, that URL, and the country we want the proxy to go from. So in our case, it would default to US. And we will construct the proxy URL, passing in our payload as query params. We will then return this proxy URL and import URL encode from the URL lib library. Now when we make a request, it will go through a proxy provided by ScrapeOps. Let's replace our URL with a call to the getScrapeOps URL function, passing in our location. And to run this, we will activate a virtual environment, run the scraper, and now you can see that results have been returned and saved to our CSV file. So that's to get a list of products, but to do a single product individually, we can create a new function called parseProduct that takes a product object, a location, and a number of retries. We will get the URL from the product object, define the number of tries, and set success to false. We will construct a product URL, which in our case will be the individual product URL you would see on Amazon. We will then split the URL by a / and set the title and the ASIN. We can then print the ASIN and title. And similar to before, while the tries is less than or equal to the number of retries and we are not successful, we can do a try and accept, whereby in the try we make a request to the product URL, and in the accept we do some logging. We can do a logger.warning to say that we failed to parse that page, and we can increment the number of tries by 1. If the response from Amazon was 200, then we can print that the content was fetched successfully, and we can pass that payload into BeautifulSoup. Now we can start extracting some data from the payload. we can find all spans and loop through each span. And for each span, we can find spans within that span to get a list of images and iterate over those. And if that image span is not known, then we can find the image tags within it and loop over each one of those and pull out the URL using the source tag. We are now checking that the URL starts with m.mediaamazon.com to make sure it's an Amazon media link and that it's not already in the images to save list. We can then append it to that list, and then we can define a list of features and get those list of features from the soup using the class A spacing mini. We can then iterate over each one of those features, pulling out the text and appending it to features if it's not known. We can then pull out the price using a span that has the class A price symbol, and we can find the whole number in a similar way. We will replace commas here with, we can get the decimal by finding the span with the class A price fraction, and we can convert the price to a float. We can then define a dictionary with all of this data, similar to how we did it before. We can paste in a list of features and a list of images. In this case, we will take the first 4 if they have values, and if they don't, we will use NA. We can print that product data, set success to true, and if the status code was not equal to 200, raise an exception saying we failed response from the server. We will then create a function called threaded item lookup that takes a CSV file name, a location, retries and threads as arguments. We'll open the CSV file. We will read its contents. And for each product object in that file, we'll iterate over it and call the parse product function, passing in the product object, the location, and the number of retries. In our main function, we will define a list called aggregate products, and when we are parsing each product, we'll also append the file name to that list. And then once we've parsed all the products, we will loop over every product in the aggregate products and call the threaded item lookup function, passing in the product, location, and threads. Just like before, we want to take this data and put it into a data class. So we can define a data class by saying @data class. And just like before, we will define all of the fields in our data class. We'll paste in our 4 features and our 4 images. We will create a post init function, which again will run after the data class has been initialized to check string fields. We will create a check string fields function, and its main purpose is to loop over every field in the data class, check to see if the string is empty, and if it is, set it to some constant value. However, if it is a string and it's not empty, we will just strip any trailing spaces. Now we can define a product pipeline in our parse product function, similar to how we did it before, passing in a CSV file name. And then we will replace our item data with a call to our new data class. And we will append that to our product pipeline by calling product pipeline.addData. And then we can close the pipeline. To add concurrency to this, we can go back to our threaded item lookup function and again create an instance of executor using the thread pool executor, passing in the max workers. We can create a list of futures, and for each one we can say executor.submit, passing in the parse product function, the product object, location, and retries for each product in reader. Then we can loop over each future and call future.result. We'll probably get blocked by Amazon for this request, so to bypass that, we can put in a call to get scrapeops URL. We can activate our virtual environment, and now when we run the script, you can see a bunch of files get created, and these are the individual product details with the images, etc. So that's it. You've learned how to scrape an entire page of results and an individual page from Amazon with BeautifulSoup and scrapeops, and save it all to a CSV file. If you want to get your own key to handle the proxying, be sure to check out scrapeops for more information. If you have any questions, please leave them below. And also, don't forget to like, comment, and subscribe.